Good evening. In this session, I am going to discuss something about an electric dipole. So, an electric dipole, two equal unlike charges separated by a distance form an electric dipole. This is plus q and this is minus q separated by a distance 2L. So, that arrangement where two equal opposite charges are separated by some distance is called an electric dipole. So, dipole moment. Dipole moment is represented with the letter P bar. It is equal to 2LQ. See here, dipole moment is a vector because I wrote P bar already. So, out of 2L and Q, which is the vector, you guess? Is the length of the dipole a vector or is the charge a vector? We know pretty much well charge is a scalar. So, here length of the dipole is a vector. So, dipole length is a vector directed from negative to positive. Dipole length is a vector directed from negative to positive. Hence, dipole moment P is a vector from negative to positive. This is very important, negative to positive. So, when two equal unlike charges are separated by distance, a dipole is formed. Dipole moment is the product of dipole length and the charge 2LQ. Length of the dipole is a vector directed from negative to positive. Hence, dipole moment is also a vector directed from negative to positive. Okay. Next, we are going to see, just I will give you an example problem which is given in the previous examinations. Three charges are placed at the three corners of an equilateral triangle of side A. This is plus q, this is plus q and this is minus 2q. So, three charges are placed at the three corners of an equilateral triangle of side A. So, the charges placed are plus q and minus 2q. The question asked is, what is the net dipole moment of the system? See here, to find the net dipole moment, we are dividing this charge into two parts, minus q, minus q. So, minus q plus q, this is one dipole whose dipole moment is in this direction. Minus q plus q, that is another dipole of dipole moment in this direction. As this is an equilateral triangle, that angle is 60. So, when two dipoles of dipole moment P are at 60 degrees, from the concept of vectors, the resultant of two vectors of same magnitude which are at an angle 60 degrees is given by root 3p. You have to, because the resultant of two vectors of same magnitude is 2p cos theta by 2. So, here this is 2p cos 60 by 2, 30. This is 2p root 3 by 2, 2 and 2 gets cancelled, it is root 3p. Very obviously, if you need to do all those things in the examination, you are not scoring 99 percentile anymore, because they are the fundamentals, you should have them on your text. So, when two vectors of same magnitude or at an angle 60, resultant is root 3p. So, here this is root 3, p is dipole length and charge product. So, here length of the dipole is nothing but the side of the equilateral triangle. So, the answer for that problem, find the resultant dipole moment of the system shown. So, that is root 3 AQ. Is it okay? Now, let us try to find out electric field intensity at any point on the axis of a dipole. So, electric field intensity at any point on the axis of a dipole. On the axis of a dipole. See, look here. This is a positive charge and this is the negative charge of the dipole. So, let us consider a dipole of length 2L, charge Q and dipole moment P. Here, if you draw a line joining the two charges, this becomes an axial line. Let P be a point on its axial line which is at a distance r from the center. Okay? So, this is a dipole of charge Q. So, this is plus Q, this is minus Q and length 2L and the dipole moment P. So, P is the product of length of the dipole and the charge. Here P is a point on its axis at a distance r from the center. At the point P, we want to find E. See here, let us treat that dipole as two individual charges. First, due to this negative charge, electric field intensity at that point is En. Due to a negative charge, electric field is towards. So, that is En is equal to 1 by 4 pi epsilon naught q by distance from the center is r. So, this distance becomes r minus L. So, 1 by 4 pi epsilon naught q by r minus L whole square. Similarly, at this point, due to this positive charge, electric field intensity is away. Let us, because due to a point charge, electric field is away. So, electric field at that point P due to the point charge, positive charge of the dipole is 1 by 4 pi epsilon naught q by, what is the distance of this point from this? This distance is r, this distance is half the length, half 2L and that is L. So, it is q by r plus L whole square. The resultant field at any point due to number of charges is the vector sum of the individual fields. See here, when two vectors are in opposite direction, resultant field will be P minus Q. See here, as a negative charge is closer, its magnitude is more, it is En minus Ep. So, 1 by 4 pi epsilon naught Q, let us take it as common factor from these two expressions, 1 by r minus L whole square minus 1 by r plus L whole square. This is 1 by 4 pi epsilon naught Q, r minus L whole square into r plus L square, L whole square is the LCM. So, r square minus L square whole square. This is r plus L whole square minus r minus L whole square. What is the formula for a plus b whole square minus a minus b whole square? 4ab. So, using that relation, it is 1 by 4 pi epsilon naught q 4ab by r square minus L square whole square. Okay. Now, look here. Out of this 4L, let us take 2L outside. 2L into Q is P. So, that expression becomes, what happens to that expression? 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught Q 2L into 2R by R square minus L square whole square. Okay. 2LQ is nothing but P. So, 1 by 4 pi epsilon naught 2PR by R square minus L square whole square. That is the expression for electric field intensity at any point on the axis of an electric dipole. Look here, this is the expression, and this will be in this direction. Resultant will be in the direction of En. Now, so I am rewriting the same expression. At any point on the axis, electric field intensity 1 by 4 pi epsilon naught 2 p r by r square minus L square whole square. Okay. In case of a short dipole, dipole length is very small, so L becomes negligibly small compared to R. If you neglect that, E is equal to 1 by 4 pi epsilon naught 2 p r by, if you neglect this, r square whole square, r to the power of 4. So, E is equal to 1 by 4 pi epsilon naught 2 p by r cube. That is the expression for electric field intensity at any point on the axis of a short dipole, right? And the direction is from, in this direction, that is from negative to positive. Negative to positive. That is the entire derivation for electric field intensity at any point on the axis of an electric dipole. So, here we need to remember, you should have the concept in mind very obviously. So, this is the dipole and let P be a point on its axis at a distance r from the center. At P, electric field intensity is 1 by 4 pi epsilon naught 2 p r by r square minus L square whole square. In case of a short dipole, L is very much less than r, E is approximately 1 by 4 pi epsilon naught 2 p by r cube, and the direction of electric field intensity on the axis of an electric dipole is always from negative to positive. At any point, if you consider here, this charge will be dominating and electric field intensity is again in this way. So, electric field intensity at any point on either side of the dipole, it is always from negative to positive. In the recent exams, one question is asked, what is the angle between electric field and dipole moment? What is the angle between electric field intensity at any point on the action line of a dipole and the dipole moment? See, dipole moment is from negative to positive. Here electric field is also from negative to positive. So, electric field intensity and dipole moment are in the same direction at any point on the axis. So, angle between them is equal to 0. So, next let us go to an expression for E at any point on the equatorial line of the dipole. Equatorial line of the dipole. Look here, let us consider an electric dipole of charge q, length 2L and dipole moment P. Okay. Now, equatorial line is the line, this is the line, this is the center of the dipole, this is the equatorial line. Let P be a point on the equatorial line. See here, if total length is 2L, this length becomes L and this is at a distance r from the center of the dipole, and this distance will be square root of r square plus L square, and this distance is also equal to square root of r square plus L square. Now, we are treating the dipole as two individual charges. At the point P, we want to find the resultant field due to two individual charges. we need to find out the vector sum of the individual fields at that point. So, due to this positive charge, electric field is in this direction away. Due to the negative charge, electric field is in this direction towards. The resultant of these two will be the electric field at the point P. Now, let us try to find out electric field intensity at that point due to the positive charge first, EP. So, 1 by 4 pi epsilon naught into Q by this distance R square plus L square under root whole square. So, it just becomes 1 by 4 pi epsilon naught Q by R square plus L square. Due to this negative charge, 1 by 4 pi epsilon naught Q by square of this distance is again R square plus L square. That is EP and EN are equal in magnitude. Okay, so we need to find out the resultant of these two. See here how to find out the resultant of two equal vectors. If this angle is theta, then E is equal to resultant of two equal vectors. Look here, E is equal to 2EP cos theta by 2. Resultant of two vectors of same magnitude is 2p cos theta by 2. Here 2EP cos theta by 2. So, this is theta by 2. So, this is 2, EP is this expression 1 by 4 pi epsilon naught Q by R square plus L square cos theta by 2. If this is theta by 2, this is theta by 2. Adjacent side, suppose if you consider this triangle A, O, this is B, say this is C. So, considering the triangle AOC, what is cos theta by 2? Adjacent side by hypotenuse, root of R square plus L square. So, this is 2LQ, 1 by 4 pi epsilon naught 2LQ is P by R square plus L square to the power of 3 by 2. This is the expression for electric field intensity at any point on the equatorial line of a dipole. If that dipole is a short dipole. So, in case of a short dipole, L becomes negligibly small compared to R, then E is equal to 1 by 4 pi epsilon naught P by L becomes 0, R square to the power of 3 by 2 is R cube. So, in case of a short dipole, electric field intensity on its equatorial line is 1 by 4 pi epsilon naught P by R cube. It is directed from positive to negative. So, angle between this field and the dipole moment becomes 180 degrees. On the axial line, E is from negative to positive. On the equatorial line, the direction of E is from positive to negative. So, it is the angle between this electric field and electric field and the dipole moment is 180 degrees. Okay. So, here now I am asking you one question, you have to answer me properly. Look here, what is the expression for E at any point which is at equal distances, from each charge of the dipole. So, here let us consider the dipole like this. This is positive charge, this is negative charge. So, it is at equal distances. Where should the point lie? One is exactly at the center, we do not find it exactly at the center, and the next possibility is at all points on the equatorial line, distance from each charge is same. Okay, so at equal distances, x from each charge, meaning that point is lying on its equatorial line at equal distances. If this is r, this is l, x is nothing but root of r square plus l square. So at any point on the equatorial line, we already derived the formula as p by r square plus l square to the power of 3 by 2. This is nothing but 1 by 4 pi epsilon naught p by x cube. If you take r square plus l square under root as x, this is nothing but x cube. So it is such a simple question. At any point which is at equal distances from each charge, electric field intensity is 1 by 4 pi epsilon naught p by x cube. Okay, so you have to understand that point is lying on its equatorial line. When once you get that concept, it is done. Okay, next problem or next thing, look here. At any point on an arbitrary line of an electric dipole, which is a short dipole. At any point lying on an arbitrary line of a short dipole. Now look here. This is the dipole with positive charge plus q. This is positive charge plus q. This is minus q. This is the axis of the dipole. Now this is the arbitrary line making an angle theta with the axis of the dipole. Let P be a point which is at a distance r from the center of the dipole. At that point P of this short dipole, we want to find out the electric field intensity. So this is a short dipole of length 2L, charge Q, dipole moment P. P is a point lying on an arbitrary line making an angle theta with the axis, and the point is at a distance r from the center. Remember, there are so many ways of solving that problem. I feel one method is the easiest, so I am going to that method. Now this is a dipole of dipole moment m, dipole moment p, negative to positive. So we treat this as a dipole of dipole moment p in this direction. We are resolving that into two components. See here, one is in this direction and the other is in this direction. If this angle is theta, this angle is theta, this component becomes p cos theta, this component becomes p sin theta. So we are assuming that dipole as the combination of two dipoles at right angles to each other, this as dipole moment p cos theta, this with the dipole moment p sin theta. Now look here, this point P is on the axial line of this dipole, isn't it? It is on the axial line of this dipole. At any point on the axial line of the dipole, electric field intensity is along the dipole moment. So here E1 is equal to 1 by 4 pi epsilon naught to, here instead of p we need to take cos theta, 2p cos theta by r cube in this direction. Is that all right? Now considering this as another dipole, this point lies on the equatorial line of the dipole. At any point on the equatorial line of the dipole, electric field intensity is from opposite to the dipole moment. So it is in this direction. This is E2 is equal to 1 by 4 pi epsilon naught at any point on the equatorial line, electric field intensity is 1 by 4 pi epsilon naught P by r cube. Here we have to take P sin theta by r cube. So, this is the most important thing. See here, these two are at right angles. So, the resultant field will be in this direction. So, here if you take this as alpha, so first of all the resultant of these two, E is equal to root of E1 square plus E2 square. So, in this E1 and E2 we can take 1 by 4 pi epsilon naught P by r cube as common factor outside. The remaining is 2 cos theta. So, root of 2 cos theta whole square, 4 cos square theta, plus the remaining is sin theta here, sin square theta. So, this is 1 by 4 pi epsilon naught P by r cube. We are writing this as 3 cos square theta plus cos square theta, this 4 cos square theta plus sin square theta. So, cos square theta plus sin square theta is 1 by 4 pi epsilon naught P by r cube root of 3 cos square theta plus sin square theta is 1. So, electric field intensity at any point on an arbitrary line of a short dipole is E is equal to 1 by 4 pi epsilon naught P by r cube root of 3 cos square theta plus 1, and it is along this direction. So, with that arbitrary line, it is making an angle alpha given by tan alpha is equal to opposite side, that is E2, by adjacent side, that is E1. See here, E2 is P sin theta by r cube. So, P sin theta by r cube. E1 is 2p cos theta by r cube. So, you will be left with 2 cos theta. If you divide E2 by E1, it is sin theta by 2 cos theta. Sin theta by 2 cos theta, this is equal to tan theta by 2. This is very important. Here alpha is the angle made by the resultant field with the arbitrary line, then tan alpha is equal to tan theta by 2. So, we could find the expression for the magnitude and direction of electric field at any point on the arbitrary line of an electric dipole. So, you have to be thorough with all these concepts by the next class. So, you have to derive everything, you have to practice everything, then you have the formulae in your mind. You have the concept in your hands and you have the formulae in your hands, only then you can apply all those formulae to the problems. Thank you and bye-bye.